the exit plan of astronomers has found using our new 10 billion toy. It will be years before that project becomes a reality. If it goes as planned, the journey to Proxima B will take about 20 years, so realistically, it will be several decades before we can confirm if there is indeed life on that planet. The age-old question of whether we are truly alone in this universe persists. The James Webb Telescope has discovered some terrifyingly humanesque things far, far away from Earth that lead us closer to the answer. Our search for life outside of us has been rampant throughout each human civilization, so much so that we have thousands and thousands of media, literature, and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion, no matter how alien-like we might be. We might be getting closer and closer to the answers we truly want, but are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we might not be prepared to witness. Lights far, far away. Scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, such as Proxima B, the closest exoplanet to Earth. Proxima B, about 4.25 light-years away, was believed to be tidally locked with a permanent day-side and night-side, similar to our moon. A hypothetical technological civilization on Proxima B might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity from starlight. Subsequently, in a paper with Manis V. Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima B. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and greater range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri B's secrets. Throughout history, humans have wondered about the nature of the universe, what we are, where we come from, and where we go. These are common yet extremely difficult questions that mankind has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one wonders if we are any closer to answering these questions. If you were to ask a philosopher, he might say we are still at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans have made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers through the technology we harness. A specific creation of that technology is now responsible for the recent discovery of what might be light on a different planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who's out there? Where do we begin and where do we end? This infrared astronomy tool has already begun answering these questions, although partially. First, you might find yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet and orbits an M-type star. Super-Earth exoplanets might confuse you, but do not worry, as this text will quell all your burning questions. Super-Earths are a class of planets that are more massive than Earth, yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth to 10 times its mass. They really put the super in super-Earth. As for Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, first detected in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These marvelous discoveries are orbiting an M-type star. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have very low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of 3000 K, hence getting their name and attributes. Coming back to Proxima B, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can estimate the size of the star Proxima B is orbiting. Staggeringly, under the measurement of the entire electromagnetic spectrum, the star has a total luminosity of only about 1.6% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 5 to 6% of the Sun's luminosity in the visible light spectrum, emitting a significantly lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.045 to 0.056 Australian dollars away from its star, Proxima B's discovery was announced way back in 2016. You might be wondering why Proxima B? With millions of stars, planets, and galaxies, why are we so fixated on this particular celestial body? Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence why Proxima B, our closest known star, is high up on the priority list at the moment. It is also a part of the triple star system called Alpha Centauri, and although Proxima's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri B is that it might potentially be habitable since it falls under the habitable zone. The possibilities surrounding the star are endless, and thus astronomers have taken on the expedition to explore the depths and limits of the potential of the star. That is where the James Webb Space Telescope comes in. The 4 key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions, from searching for exoplanets to searching for alien life. So what exactly is said, one might ask? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked with being on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond our wildest dreams. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes game of hide-and-seek, with our planet as the seeker and the vast universe as the seemingly infinite hiding spot. It is one of those fields where scientists are modern-day Sherlocks, tuned into radio waves and scouring for that elusive, "we are not alone" moment. This game of cosmic eavesdropping began in earnest in the 1960s. Frank Drake, a man who could make even Einstein say, "Now that's a smart cookie," pointed a radio telescope at 2 sun-like stars and listened. Although he was greeted with the sound of silence, Drake's equation, an algebraic recipe to estimate the number of civilizations in our galaxy, set the stage for generations to come. Fast forward to now, and SETI has turned from a backyard science project into an interstellar endeavor. Scientists use an array of tools, from the giant Arecibo telescope to the Allen telescope array, a network of dishes that looks like a high-tech crop circle. The aim is to catch that one peculiar signal, a blip or a whisper that says hello from another world. These are radio signals that SETI typically hunts for, the kind you might hear on your FM dial just with a touch more stardust. But in 1977, a signal named "Wow" was received. It was a radio burst so distinct that it made the astronomer who found it write "Wow" in the margins of the data printout. Was it ET phoning home? Not quite clear, but it fueled the fervor to keep the ears of our giant dishes open. However, just listening is not enough anymore. With advancements in technology, SETI now looks for techno-signatures, signs of technology, the kind that would indicate a civilization advanced enough to produce them. Picture this: an exoplanet bathed in the glow of city lights or covered in solar panels glistening under an alien sun. SETI's New Age quest is to spot these artificial lights or industrial pollutants in alien atmospheres, an alien world's equivalent of finding candy wrappers left behind in a cosmic park. These efforts tie in beautifully with the James Webb Space Telescope's mission. The JWST, with its sharp infrared vision, could be the cosmic detective that helps SETI spot these techno-signatures. It's a tag team of sorts where the telescope finds the planets and SETI listens in for the telltale signs of intelligence. SETI, although ambitious, faces its fair share of challenges. Space is mind-bogglingly huge, and signals can be as elusive as finding a needle in an intergalactic haystack. There's also the cosmic speed limit. Signals from civilizations millions of light-years away would take eons to reach us. Yet despite the odds, the search continues, fueled by the possibility of one day finding out that in the grand cosmic drama, we are not the only players. The recent discovery using the JWST might just be the biggest find in this hide-and-seek game. This groundbreaking revelation may imply that Proxima B has artificial lights on its dark side. However, what does that actually mean? Does it imply that a civilization intelligent enough to use tools similar to ours exists? Have we found friends? Are we truly alone in the universe? The very idea of this discovery is terrifying as there is so much more to learn. But more importantly, the endless number of possibilities is the truly terrifying part. Let's dive into the details and see exactly what this means. Imagine a hypothetical scenario. You are looking up at the night sky, gazing at a distant planet through the lens of the James Webb Space Telescope. As you peer deeper into the darkness, you spot something that should not be there. Faint twinkling lights dotting the night side of Proxima B, a planet orbiting the nearest star to our Sun, Proxima Centauri. These lights are not random but appear in patterns too regular to be natural. Could this be evidence of an alien civilization? The hypothesis that these lights are artificial in origin stems from a thought experiment conducted in 2021. The idea was simple yet profound. If there were a technological civilization on Proxima B, especially one on a tidally locked planet, how might they illuminate their dark side? In the case of Proxima B, it is likely tidally locked, meaning one side perpetually faces its star while the other remains in eternal darkness. This scenario would necessitate the transfer of energy from the day side to the night side, perhaps through photovoltaic cells generating electricity from starlight. Detecting such an arrangement with current or near-future telescopes was initially a theoretical exercise. However, the capabilities of the James Webb Space Telescope, launched in December 2021, have turned theory into potential reality. The JWST's advanced instruments, particularly its near-infrared camera, NIRCam, and mid-infrared instrument MIRI, are designed to detect faint signals from distant celestial objects. These instruments allow astronomers to observe exoplanets in unprecedented detail, potentially revealing artificial lights or other signs of technology. Fast forward to 2024, and there are whispers in the scientific community that the JWST may have detected such lights on Proxima B. This discovery is monumental for several reasons. First, it challenges our understanding of the cosmos and our place within it. The presence of artificial lights on Proxima B suggests the existence of an advanced civilization capable of harnessing and utilizing energy in ways similar to or perhaps beyond our own capabilities. This finding would be a game-changer in the search for extraterrestrial intelligence, SETI, providing the first concrete evidence of life beyond Earth. Second, the implications for science and technology are profound. The discovery would spur a new era of research focusing on understanding the nature of this civilization and their technology. What kind of energy sources do they use? How do they manage their resources on a tidally locked planet? These questions could lead to advancements in our technology and our understanding of sustainable energy solutions. Lastly, the ethical and philosophical implications are equally significant. The realization that we are not alone in the universe raises questions about our responsibilities as a species. How should we approach contact with this civilization? What are the potential risks and benefits of such an encounter? These considerations would shape the future of space exploration and international cooperation in unprecedented ways. The detection of artificial lights on Proxima B by the James Webb Space Telescope is a landmark moment in human history. It not only answers the age-old question of whether we are alone in the universe, but also opens up new avenues for scientific exploration and technological innovation. As we stand on the cusp of this new era, we must approach it with curiosity, caution, and a profound sense of wonder at the possibilities that lie ahead.